Okay, so moving on to our next example, we have an example 3 here. So, in here, makikita nyo rin to siya sa ating manuals, okay? So, sabi dito, early in the morning at the beginning of trip, okay, the tires of an automobile are cold, no, which has a temperature of 280 Kelvin, and their air is at a pressure of 3 atm. Later in the day, no, so siguro nag-travel siya from Marawi to Iligan, okay? Then later in the day, no, yung nung tumaas na yung araw after a long trip on hot pavements, okay? The tires are hot, no? So which has a temperature na 330 Kelvin. So what is the pressure? Yun yung tanong, what is the pressure? And then may assumption siya dito na sinabi, sabi niya, assume that the volume of the tires remains constant. So ibig sabihin, pag volume is constant from your manuals, it may be gay lo sa aklo, no? Gay lo sa aklo. Okay? Okay. So take note that here, ang gagamitin natin pa rin dito is yung ideal gas law, but there is a additional concept in which the three quantities for ideal gas has one quantity that is constant, no? So in here, sa case na to, ang constant dito is yung volume. Okay? Now, we have a note here, sabi niya, at a constant volume, the pressure is proportional to the temperature, no? Yung tama, no? Bakit? Kasi kung titingnan natin yung ideal gas law natin, we have PV is equals to nRT. Okay? So pag constant yung volume mo, therefore matatawag na natin siya, since constant din yung number of moles mo at saka yung R, your universal gas constant mo, constant pa rin siya, we can just say that V is equals to constant multiplied by temperature. So therefore, V mo is directly proportional kay T, no? Kung papalakihin mo si T, lalakihin si V. So yan yung condition ng constant volume. Okay? So take note that it is only used for ideal gas, ha? Okay? Baka gamitin niyo rin siya sa ibang condition. Okay? Now, so meron tayong step here. So for step number 1, manipulate the ideal gas law equation to relate the pressure and temperature at a constant volume. Okay? So dapat yun, yung kagaya ng ginawa natin dito. Okay? So assume natin na yung volume natin is constant. After that, kukunin natin yung pinaka-original form ng magiging original or magiging derived form ng ideal gas equation natin. Okay? So we have in here PV and RT. So since yung NR dito, yung N at saka R dito is constant kasi yan lang naman yung number of moles at saka yung universal gas constant. So lalagay na lang natin na constant. Tapos when we assume that volume is constant, so mangyari is P multiplied by constant kasi volume, tapos equals to constant, yung constant dito, tapos temperature, we can now just say that P over T is equal to constant. Okay? Kasi here, itong constant na to, divide mo dito, itong constant na to, divide mo siya ng ito, tapos itong P, transpose sa kabilang side. So, we have P over T is equals to constant na lang. Okay? So, ano ibig sabihin nito? Pag yung P over T mo is constant, ibig sabihin yan, kahit anong situation or kahit anong phase or kahit anong situation, your P over T or the division of P over T mo, okay, is always constant. That's why in here, nilagay ko dito na P1 over V1 is equal to P2 over V2. Okay? So, kumbaga, ito yung condition mo para maging constant yung P at saka V mo. Dapat, i-divide mo sila para maging constant sila kahit anong case. Yun yung ibig sabihin yan. So, therefore, since inahanap natin dito sa taas is yung pressure na pangalawa, so we have to solve for this one, no? Solve for P2 here. So, solving for P2 here, we have P2 is equals to T2 over T1 multiplied by P1. So, ito yung gagamitin natin na equation or ito yung tinatawag ko na derived formula from the ideal gas equation. So, step 2 we have to substitute the value. Okay, so meron tayong pressure na 3 atm, tapos meron tayong temperature na 330 Kelvin, 280 Kelvin, yung T1 mo, yung original mo. So, divide this one, cancel out yung Kelvin mo na units, divide both side, divide this 320 divide by 280, tapos multiplied mo kay 3, so the result is 3.5 ATM. So this will be now the final answer.